Alright, so this is my program I'm calling Baby Checkers, and here it is. So, first thing I'll say is that I do believe that Python is a lot more, relies a lot more on indentation for cleanliness rather than brackets. So, in Java we have a lot of our curly brackets to show the start and ends of our functions. When it comes to this, it's really all about indentation, Our functions kind of get started by these things, and they ultimately don't have much of an end. It really only ends when the indentation goes down. So, an example here is we have our definition here on the bottom, and then we indent here for the if statement, we indent one more for the return, and then we go back to signal the end. So that's a big thing. There's a lot of really cool string methods that were very useful. So, for example, this right here, very simple to get a letter from a string. All you have to do is just put the string and then the number, really, an index of what you want. You don't need to have these like character methods set up on it. So that's pretty awesome. Makes things a lot easier to extract from. So let me talk about the actual program. So this is like checkers, but very, very easy, I don't have combos or anything crazy. It's just meant to play it in the simplest way, for someone who's never played it, to just get a gist of how to move the pieces, all that stuff. So it starts up here with a 2D array, going from 1 to 8 on the rows and A to H on the columns. So let me run it here, and this is actually how it'll look when you run it. As you can see here, we got the rows up here, we got the columns down here, and then your pieces are neatly arranged like they are in real checkers. Now ultimately, where this all starts is the main method, right? So you have your turn counter, which is at 0. This is how we get this is how we know whose turn it is in the game. So for instance, right now it's even, so it's X's turn. But if it was an odd number, which it will be after this, it would be O's, and so forth. And we get that from this method here. So if the remainder of this is equal to 0, we return true, which means that it's X's turn. But if it's 1, then we return false, meaning that it's O's turn. And as you can see, I have some if statements in the main method to separate this. So yeah. So print here, it's X's turn. And now it asks us which piece to move. Now you want to enter in your row letter and your column number. So I'll try C3. And in which direction, left or right? So we'll do left. Now you can only go diagonally with your pawns, obviously. So, or with your pieces. So when I say left or right, I mean diagonally up left or diagonally up right, So I moved left, so as you can see now, C3, our piece C3 has moved to B4. And now it's O's turn. So which piece to move? Let's go F6. F6. Left or right, we'll move left again. There we are. So now our F6 piece is moved to E5. Now, how do we do this? How do we move the pieces? So this is the big method. This is what the brains of the operation is. So we take in a piece, which is basically like what we said here, F6 or C3, our location, which is just our direction, left or right, and level, which is just the best name I could come up with for whose turn it is, basically. So we have a column, which goes back to this method here. I'll explain what this is. So there's a letter and a number in this 2D array that like everything corresponds to, right? Just how a real checkerboard is. However, I had to make something to make it so we could get a number from that, because putting a letter in isn't going to help us find the spot on the board, obviously. So I had to find the numerical counterpart, and that's what I built here. So I have a for loop going through 8, and I have a current letter or current character that I find with this index. And if this character is equal to the first letter in the string. And the string, by the way, is, let me find it here. It's our piece. And since it's the 0, the index is 0, it's the first one. So, and the first of every one, because this is how you write it, is F, or letter anyway. So F for this one, C for this one. So it takes this, and if it equals that, then it returns the index +1, because ultimately it's actually 1 to 8, not 0 to 7, because we have this extra thing here that blocks it off. So that's the beauty of this, actually, is that you can, for the most part, type it in exactly the way that you normally would, and computer science doesn't get in the way. You don't have to really do a whole lot. It automatically is in there. That's also why this is so useful, because this is 0 effectively, but because of the way I had to build this, it doesn't correspond to anything. So it's a lot easier that way to. It's a lot easier for a normal person to understand who doesn't understand, indices or anything like that. So that's a nice little bonus. So now we're back here. We have our letter to number, and then this is easy. We just take the number from it, which is a lot easier to do. We don't have to convert anything. Now, if column does not equal -1, because if someone makes a mistake, for instance, and puts in like, R6 or something, then it'll just say no valid space was selected, right? Simple as that. And then we ask, what is the location? And if it's left, then we also ask them after that whose turn it is. So if it's true, meaning that it's X's turn, then there's a special thing we do to move it for X in specific. And again, this is only if you're going left for X. So you move, for instance, if it was C3, we would move up 1 row, and then we would add something to our row counter, and then we would subtract from our columns by 1 because we're going to the left. Now, if we were to do that going right, it would be the same. We'd be going up 1 row, but we'd be going to the right 1 time instead of to the left. And then when it comes to O, it's a little bit different, because the big difference is that we're going down in rows. Or actually, because technically this is backwards, we're actually technically going up, but I would still say we're going down if you look at the counting here. We're going down 1 row, and then it's the same when it comes to the columns as X. It's if you're going to the left, you're subtracting 1 column. If you're going to the right, you're going forward 1. So that's ultimately how we do this. It's pretty cool. And if there's not a good direction, like if someone doesn't add in left or right, then it just says, did not specify a direction in which to move. And now ultimately, how do we know when the game's won? Well, that's what this final one's for. Is won is here to tell us if we've won or not, because ultimately this whole thing is run on this while loop, and it will keep going as long as this function is false. Ultimately, what's supposed to happen here is that if you can't find any one of these O's at all, then you return false. Or if you can't find any one of these X's at all, then you return false as well. Let's, with that said, let's try playing some more here. So it's X's turn again, and we will play our E3. How about E3? And we'll go to the right. And it's O's turn. Now we're in a position to take on the O side, so we will take. So O, E5. We'll take E5 and move to the right. Boom, they've taken. So one difference is that there's no jumping over people. It's just straight taking. We're just running them over almost. We're just sitting on top of their space and squashing them almost. So now X can do the same back. So we'll go G3. And we'll go to the left. And boom. So you ultimately do that until there's no pawns left. You either get something saying X wins or something that says O wins. That's about it for my program. I had a lot of fun learning this. I had limited knowledge on everything, but I do think it's pretty useful. I know a lot of people use this for like real games, real programming. Like I see a lot more people using this than Java. So I really wanted to learn it because I think it would be very helpful to learn in the future. It's definitely not too bad to learn coming right out of Java as well, compared to like probably something like C# or whatever. So yeah, this is very good, and it's been an honor being your student, Miss Lethbridge. Honestly, it's been been really good. And hopefully we cross paths again in the future, you know? Thank you so much.